Looking forward to this session with all of you. To kick things off, we're going to do some introductions of the Mountain Rain or Snow team. We'll take your questions on Slido, and after that, we'll do live questions. So if in the course of today's AMA, a new question occurs to you that you didn't have a chance to submit already, you are welcome to pop it in the chat. All of our team will be keeping an eye on the chat, and once we finish the Slido questions, if we see some questions in the chat that we like, we'll call on you to unmute yourselves and ask your question live. We will be asking everyone to keep themselves on mute in the meantime, just to reduce distractions and background noise. Most people are really good about that in these Zoom-filled times, but it is a good reminder for everyone. So without further ado, let's get started. Welcome to our first Mountain Rain or Snow Ask Me Anything session, or AMA. I'm Megan Collins. I'm the person behind the text message alerts. So when you reply directly to that text message, you are sending something directly to our text message app that appears on my phone. And I love hearing from all of you. It is a lot of fun to be one of the people-facing team members. My background is science communication, and I love working really closely with scientists to create projects like this. I'll next pass it to Keith to introduce himself.
Hey everybody. First, to echo what Megan said, it's great to see you all, and I hope this goes well and you get a bunch of useful information about the project, who we are, and what's happening over the coming months. I am the principal investigator for the NASA-funded project to which you all contribute, and we are extremely appreciative. My background is in snow hydrology, specifically the modeling and monitoring of mountain snowpacks. And I got into that because I thought that would be a really great way to ski at the same time as I do work. And I was 100% correct. It was a great way to ski and do work at the same time. I'm mostly behind a computer these days, but still get out into the field whenever I can. And with that, I will pass it over to our next question answerer, who is Josh Sturdivant.
Thanks, Keith. Hi, everyone. My name is Josh Sturdivant. I am a water resource scientist. I work a lot with hydrologic models, oftentimes using them for stream flow forecasting. So looking at, what is the stream flow going to do next week, or even what's going to do 3 months from now once our snowpack melts. I have been involved in this project only beginning this winter. And I am primarily working to engage folks in the Colorado region. I'm based here in the Front Range of Colorado. And so I'm excited for all of you here in the Colorado region where we have some snowfall today. And I'm going to pass it over to Ben Hatchett.
Cool. Well, thanks everyone for joining. My name's Ben Hatchett. I'm a research professor at DRI and work a lot with Megan on a variety of different projects ranging from science communication to paleoclimate and future climate modeling. I work with a lot of hydrologists, earth system modelers, kind of span a lot of different disciplines and have a lot of fun with various problems in weather and climate extremes, all the way from the millennial scales to the seconds to minutes time scales. And so rain snow transition is really, really fun because it really does span those boundaries. And that's why it's so important to get your information for this, because it helps us know right when that transition takes place. And then we can look at that at the instantaneous time, and then how that manifests itself throughout the course of a season. So really excited to be part of the project, and really excited to see all the great observations coming in from you all.
Thanks, Ben. And there's one more person who is here as part of our team. Her name is Monica Arienzo. Monica, can you hear us to come on and introduce yourself real quick?
Hello, my name is Monica Arienzo. I am an assistant research professor at the Desert Research Institute in Reno, Nevada. And I'm so excited to be a part of this wonderful team of researchers here looking at the mountain rain or snow work. And my role is to help understand the observations as they're coming in, if there's any additional education we can do or any additional engagement that we need to be doing for the group to be successful. So thank you all for being here today, and thank you all for all of your wonderful contributions to the program. It's been really exciting to see how quickly this has grown this year.
Thank you, Monica and team. For those of you who are hearing some of these project details for the first time, Mountain Rain or Snow actually started as a kind of seed or pilot program in the Lake Tahoe area of California and Nevada. And we did 2 seasons of scrappy data collection where we field tested the project structure, and we were fortunate to get funding from NASA that landed earlier in 2021 that enabled us to launch the program to many more regions. And so you've probably noticed, or if you checked out our bios, we are located in many different states. Monica and I are located in Nevada, Ben is in California, Josh is in Colorado, and Keith is in Vermont. And so we've got a nice kind of longitudinal span here on the project, and we are so excited to welcome so many of you from equally diverse geographies. Let's just jump into our questions from Slido. We received many questions. I was so excited to hear what people were curious about. And the question that got the most upvotes was this. Has to do with just how often should any one person report snow, rain, or mixed during the day of a storm? And Keith is going to take this one.
Yeah, the short answer I normally give for this question is that I am a very greedy scientist. So I will take as many observations as you are willing to share. And I think that's pretty consistent across our project team. Being a research endeavor that benefits from crowdsourcing, thanks to your contributions, the more we get, essentially, the better we can answer the question, because it gives us spatial coverage that extends wide areas, as Megan mentioned, many regions, but also to get more specifically to this question, coverage in time, particularly when we get shifts from snow to rain or back in the other direction during a storm event. But essentially, the time we're limited to is about every 15 minutes. And the reason doesn't have anything to do with storms or satellites or anything like that. It's the weather data that we use to update and analyze these observations after they get collected. And I see there is a question in that regard coming up later. These weather stations, they typically, at the finest timescale, report every 15 minutes. There are some that do more frequently than that. But in general, we're looking at 15 minutes to an hour at which these weather stations update air temperature, relative humidity, or other information that we use to analyze the data later. So if it's reports coming in quicker than every 15 minutes, then usually we're missing that changeover in the weather data as well. So we might get multiple reports that correspond to different precipitation types at your home, but the weather data wouldn't have necessarily caught up to that. So sort of just coming against that limitation. But the short answer is as many as possible whenever you want, because pretty much they're all useful.
So, thanks, Keith. The next question is a great one, and it is constantly, the answer to this is constantly changing. Someone asked, how many people are recording results and are contributors rated for consistency and accuracy? So Monica sent an update last night that we have 821 people registered with Mountain Rain or Snow. So they're registered as users with the app. If you report as a guest, we don't count you in that number because we don't know if you're if we don't know if you're different from the other guests. So that's one of the reasons why we do like you to sign up. And are contributors rated for consistency or accuracy? So we don't single people out when it comes to accuracy. We do have a quality control, like kind of data filtering process, which I'll let Keith explain in a second. And we do not currently have a leaderboard that says, hey, a public leaderboard that says, hey, these are the most super users. But they do appear on our end, so we can filter it. So there are a few people that we've been celebrating that are the highest number of users. And I think in our last 2-week time period, with it being dry in most regions except for the Northeast, most of our super users came from the Northeast. So cheers to you all. Keith, do you want to just comment quickly on the quality control?
Yeah, thanks, Megan. We have 5 different ways that we quality control the observations. And for our project, that means just checking them to make sure that they are the type of information that we would want to include. And the way we do that is after we assign weather data to the observations, we can then check, do these precipitation reports fall within a reasonable air temperature range? So even though there is a lot of uncertainty in whether it's falling as rain versus snow at air temperatures near freezing, generally if it's a fair bit warmer than that, let's say 50 plus, 60 plus degrees Fahrenheit, and it comes in, a report comes in as snow, well, we're pretty confident that that's going to be rain. So we might flag an observation like that. And same with the opposite end of the temperature spectrum. If it's really cold, 10 degrees Fahrenheit, it's typically almost always going to be snow. So we saw a rain observation that would go against one of the quality control flags. We also make sure that it comes in on a day when precipitation was observed, just to make sure that the precip report corresponded with actual precipitation. We do a relative humidity check. We also look to make sure the report was close to a meteorological station. So this is how we get that weather information. It doesn't disqualify the report for being included in the analysis, but it lets us know how much quality information we're getting from that met station, because the farther away you are, the less accurate that meteorological station would be at predicting air temperature at that location. And then the last one we look at is duplicate timestamps. So if they come in, and I've done this several times, same person, multiple reports at once, we then flag those for further investigation in the analysis. But I would say the good thing, even though we have this fairly rigorous protocol, is that the quality of reports that we get tend to be quite high. So even if we remove them from the data set, the ones that get flagged, the answers to our questions seem to stay about the same. We see very little effect, which suggests that the bulk of the data we get is very high quality. So thank you.
So our next question, we can start with Keith is responding to this, but Ben, if you have insights, feel free to chime in after Keith responds. So our next question is, why don't you need to know if there is no precipitation? I've seen rain, snow, and dry within a mile at the same time. So why aren't we collecting data when it's not? Why don't we ask people to report when there's no precip?
And this one, hopefully I don't sound like a broken record, is another really good question. And information like this could be really useful for some of NASA's satellite products, where there can be difficulties in detecting light precipitation or discriminating between what may be cloud cover versus what may be no precipitation. Those sorts of problems are really tricky to solve with remote sensing data. However, our project has more of a narrower scope where we're really looking at that rain snow transition and mostly the air temperatures near freezing. I won't get too deep into it, but the origin of this project, as Megan illustrated earlier, was some work that we did in the Lake Tahoe area. And it came out of ideas of, well, we actually have a really hard, in computer models, we have a hard time of assigning rain or snow. And in some cases that will mess up our water resources forecast, flood forecasts, our perceptions of avalanche risk or traffic hazards. So we really wanted to get that rain, snow, temperature transition correct. And so we're doing that in multiple regions now because there is pretty wide spatial variability in it. But I think for another project in the future, that yes, no binary precipitation could be a really interesting question to pursue.
Ben, do you have anything you want to add, or did Keith cover?
No, I think that was pretty much what I was going to say as far as, oh, this would be a great add-on. So if we can get enough observations and make NASA happy and want to keep funding this, that would be a really neat additional aspect. Because one other thing that came up, and Megan, maybe you'll get to this question later, is in many locations, especially in mountains, the radar may not be able to actually see that precipitation is occurring because the topography blocks the radar beam. And then there's also issues with the satellites as well. And so being able to observe when you get precipitation and you're observing it, but we don't see it on the radar, that helps us better constrain whether precip was occurring, but the radar may have said that it wasn't. But then of course we could flip that and be able to say that it is nice to know when, nope, we don't see anything, nothing is observing anything. And that can also sometimes help our weather stations, which may be misrecording precipitation. Like sometimes if a tipping bucket is not heated, it may have snow that's accumulated on it. And if it gets warmer, that can melt. And then we observe precipitation when it actually isn't taking place. So yeah, I think it'd be a really nice add-on to a future study for sure. And it always gets at this interesting question of, well, where isn't it precipitating and why might that be? And what processes are controlling where the rain or snow is stopping or where it may not be observed on radar, but like in Reno or maybe in the Front Range is another good example. We get a lot of this blowover precipitation where it's like, oh, the skiing's not good, I'll go for a run. And oh, it's 40 degrees and I'm getting hit by ice pellets that are blowing from 10 miles away. And we would probably want to have that reported, but that may also not go through Keith's quality control check. So it's basically all observations are really good. But yeah, I think adding that yes/no classification to precip in the future would be really good.
Awesome. Thank you. So this next question has to do with what our team does with the data or with your observations after you send them to us. So right now, if a storm is approaching, we'll send out an alert via text message. You open the web app in your mobile phone's browser and you send us an alert. Then what happens after that? What do we do with the reports? How do we meld them all together? And what meaning do we make of it? So again, we can start with Keith, and then if there are others who want to add on and kind of look at it from because we're all coming from different scientific disciplines. If there's anything you want to add, feel free. What happens to the data after you send it?
Yeah, so first the data goes into a database, which we think can then access. So we'll download it. And the first thing that I do with the data when I'm analyzing it is I'll go through and I'll start to add those modeled meteorological data. So I also get data from meteorological stations, air temperature, precipitation, humidity, et cetera. So we basically just start adding a whole bunch more data to the mix. So not only do we have the observations, but we can also have geospatial information that could include elevation of where the observation was taken, the ecoregion, which is a way of defining different landscape types and ecosystems in the United States, state, county, city, et cetera. So we do all that. And then that allows us to analyze these data. And one of our prime analyses with the Tahoe rain or snow data, which we're going to do with mountain rain or snow, now that we've expanded to include more mountain regions, is to determine what is called the rain, snow, air temperature threshold. And that's the air temperature value at which rain and snow fall with roughly equal probability. Many cases you might think, well, water freezes at 32 degrees Fahrenheit. It should definitely be 32 degrees Fahrenheit. And one of the funny things about this project is we know what the freezing point of water is, yet somehow snow keeps falling for some reason at 33, 34, in some locations, particularly the Sierras or the Reno area, even 40 degrees Fahrenheit. So we're looking at where snow falls at what temperatures, because that is super important for hydrologic models and climate models. These are what really allow us to understand not only Earth in the past, Earth in the present, but also what can happen in the future. And if we're not getting rain versus snow right in Vermont or the Colorado Rockies or the Sierra Nevada, we don't understand the hydrologic cycle there then, because it is so important, that rain versus snow partitioning.
Any follow-on thoughts? Okay. A corollary question, which Keith, you kind of hinted at this, a corollary question that was embedded with this was, why don't you need to know the temperature where we are? Why are you asking for just rain, snow, but not the temperature at our locations?
One of the goals of this project when we first started a few years ago is we wanted the report process to be as simple as possible. So that's why we ended up going with first an iOS app or an Android app as well, and then to a web app where basically all you have to do is press a button as to whether it's rain, snow, or mixed. So you don't have to have a thermometer, you don't have to look up what the nearby air temperature might be, you don't have to know your precise location, you don't even have to know what time it is because the app will timestamp and geotag each observation automatically. So that's correct. When we get an observation, it doesn't have any meteorological or weather information whatsoever. But what we can do in the US, there's a really great series of networks of meteorological stations. In most cases, wherever you are, there are exceptions in mountain regions, but you're typically not more than 10, 15 miles away from a weather station. And air temperature has a pretty strong relationship with elevation, particularly during storm events. So that allows us to model the air temperature. So we use the specific location and time of your observation. We use the elevation, and then we use information from the nearby meteorological stations at that time that the observation was submitted, and then we correct for elevation. And the good news is that the process we use is accurate to within a few tenths of a degree Celsius. So even though you don't report air temperature, we can get those data really with a high degree of accuracy from existing meteorological stations.
And there's so many smart people on this team. Great. So this next question is for Josh. We have satellites, weather stations, and lots of technology that observes winter storms. So why do we need people to send reports of winter weather?
Yeah, thanks, Megan. While it's generally true that we are awash with different meteorological data from satellites and weather stations, other observations, it's also the case that there are very few automated observations of precipitation type. I was looking, for example, at a weather station in my back door here at Denver International Airport. And this weather station measures kind of all your classic variables, things like temperature and wind, relative humidity, pressure, and of course, precipitation. But like other weather stations, many other weather stations, they do not have any automated sensors that differentiate that precipitation to say whether it's falling as rain or as snow. And so as hydrologists and scientists, we must then resort to sort of a variety of different ways to figure out, is that precip rain or is it snow in our models that we're using? And the simplest way to do this is by using an air temperature threshold, where we set a threshold and then define, if the temperatures are above that, we're going to classify this as rain. And if they're below that, we'll call it snow. And this approach generally holds up. For example, when it's warm and humid, you're going to get rain. And if it's really cold, you're likely to get snow. But when our models are trying to predict precipitation phase from those precipitation measurements, right around freezing, they oftentimes are less skillful. This is particularly true at temperatures of about 0 to 4 degrees Celsius, when even our best models are only right when it comes to predicting precipitation type 60% of the time. And this really matters for how we simulate our snowpack, but also for our weather forecasts and understanding, say, where the elevation is going to be for that rain snow line if you're going to drive up over I-70. Is it going to be at Eisenhower Pass or above it or below it? What does that mean for you, for snowplows, and so on? And so observers really help fill this gap. And there's no better way to identify whether it's raining or snowing than through visual observation. And so we take your observations, and as Keith described, we feed them back to our models, and that helps improve our simulations and ultimately our understanding hydrometeorological processes.
Thank you so much. That was, you distilled that very well. Thank you. So our next question, I can take this. What type of feedback will participants receive? So like Keith described, what we do is we take a lot of observations and what we would do is we build probability curves. So we assess how well the current rain snow threshold or a straight 32-degree threshold or other thresholds stand up against your observations. And there are a number of other processes like Keith described, and we have been doing report backs at the end of each year, which allow you to see where the observations were made. So we made a story map, which included all the observations across space. We also help describe what these data mean, what these results mean for the scientific community. And so you can expect a synthesis like that. In addition, our team has been sharing our work within the scientific community. And there are a number of different places where you can check out more of our work. And I'm happy to share links. For example, in the European Geophysical Union blog, Keith wrote an article. We also have a publication in Frontiers in Earth Science. And we've been making frequent updates, or we will be making frequent updates to SciStarter and NASA news updates. So we like to share out as soon as we can the results of these in a way that's generalized. So we won't be giving feedback to each individual reporter like, hey, how well did I do? But we will be synthesizing them on a big scale. And Keith just popped a link to previous reports in the chat right there. Our next question is for Josh. Snowflakes can drift through the air very lightly and not for long. If it is snowing, but there is no mention of snow in the forecast, should we report that?
Yeah, I think Keith covered this as well as Ben. We will take all observations, whether your weather forecast is calling for it or not, submit away. I think the one caveat here is that there is the case in very light precipitation, if it's raining or snowing, that your observation might get filtered out of our final analysis if that nearby meteorological station doesn't measure any precip. But regardless of that, we definitely encourage you to submit all the reports, even if it's light snowfall or rainfall.
Okay, great. And diving into that, we'll sometimes receive questions if people should report freezing fog, hail, graupel. We are aware that there are many different precipitation types in addition to raining, snowing, and mixed precip. So how should we handle those?
Yeah, that's a great question. I think there's generally, with regards to those three types of precipitation phase, there's specific guidance that we usually offer. In the case of freezing fog, we ask that you don't report that, since fog is not technically precipitation and it would likely get filtered out of our analysis anyway. Graupel is an interesting case. For those that are not familiar with graupel, it's oftentimes referred to as the dipping dot snow. It's usually very light, different than hail, like a dipping dot. In this case, graupel is a type of snow that's simply been rimed over. And so we encourage you to report that as snowfall. And then hail is an interesting one. It is a frozen precipitation type, but it actually usually starts out as rain in a thundercloud that has then gone through a very different mechanism than graupel, in that it's usually uplifted to a much colder part of the atmosphere where it then freezes and precipitates out. But in that case, we ask that hail is not reported. And I think the other important thing is that we generally won't see hail during the winter months, which is really the focus of our study. It is possible to see it in the shoulder seasons in the spring or in the fall when we might have thunderstorms. But again, with hail, we ask that you simply just don't report that.
Thank you. We've got one more question that came from Slido, and then we're going to jump to the questions that are coming through here in the chat. If you have something on your mind that you want to ask, feel free to pop it in now. I'm looking at the chat, and again, I'll be calling on people to ask their question live once they come through. So we've got a question for Keith. And this is a question that we've answered a couple times through different channels, but it is good too. If you are active in the community and citizen science world, you may be familiar with a project called MPing. And so this question that came through was, how is this data, or how is this project different than MPing? Are these programs, are these programs overlapping or working together? How do these programs differ? MPing and mountain rain or snow.
I will actually flow from the tail end of Josh's question into this one because I actually think they're related. So the models that we use for climate simulations and water resources, which again help us understand not just the science of water, but also what it means to our daily lives. When it comes to precipitation, they are very simplistic. Typically, a model will only treat precipitation as rain, snow, or mixed. And that's what the model might call it. But really, it's just saying, is this precipitation that I'm getting frozen, not frozen, or a mix of the two? So these models don't know if it's graupel, if it's pellets, if it's freezing rain, if it's hail, if it's any of these things. They don't resolve it for the most part. So when we're modeling snowpacks, or we're modeling the water cycle in cold regions, it's really just, is it rain, is it snow, is it a mix of the two of them? Because that's really all they can represent. And so the one way to look at that is, oh, but there's all these other different types of precipitation. But then I think the other way to look at it is, from an annual perspective, those aren't really making up too much of the water cycle. So even here in Vermont, where we get probably more freezing rain than would be preferred, the portion of annual precip that freezing rain comprises is still quite small, maybe 2.5%, 3% in a given year. So that's why we're sticking with rain, snow, or mix, just because it's more consistent with the way those data are represented in models, and then the way they're represented by some of NASA's satellites as well. So that flows into the next question, which is MPing. It's a really great citizen science program, been around for, I want to say, 5 to 10 years. So they've really done a nice job at not only weather observation, but also natural hazards as well. Extreme wind, landslides, I think earthquakes are on there as well. I might be mistaken about that last one. But it's really kind of a full stop shop for what it's doing outside. Whereas our project has a pretty narrow remit. We're really focused on that rain versus snow, particularly in mountain areas where we tend to have almost no observations of precipitation phase, because most of the manual observations we get of precipitation come from airports, as Josh had mentioned before. And for the most part, those airports aren't located in the mountains. There are some exceptions, but if it comes to water cycle information in mountainous areas, we really just don't have much. So that was my long-winded way of saying, yes, there is overlap between the two. We all like MPing on this project, and yeah, I don't know. I think redundancy is a good thing in some cases. So we have multiple weather monitoring networks. If you want to be a scientist, there's multiple research institutes you can work at, even if they work on similar problems. So there's overlap like anything in life.
Perfect, thank you. Any other thoughts from the team before we jump into the questions from the chat? You follow on from comments or questions that have been made. Okay. So our first question comes from Bill V. Bill, do you want to unmute yourself and ask your question about warm or really cold temps?
Okay, there we go. So the question is, I mean, you mentioned that, you know, as quality control, you check whether it's really warm or really cold. I'm wondering whether you even want observations when it's really warm or really cold. And kind of on a related note, is there like a calendar start and end date for useful data for you guys?
I can answer that. Thank you, Bill, for the good question. We are primarily focused on the winter and spring months, but in terms of calendar dates, that could be kind of tricky depending where you are. Colorado, where I had lived previously, we could have 10 inches of snow the first week of September. Actually in, what was that, 2021, my son's school was closed first week of September because of a snowstorm that had knocked down trees and power lines. And then you could get measurable snow all the way into the first couple of weeks of June. So, but in Vermont, where I live presently, you're typically not going to see quite that much snow over such a wide extent of the calendar. In terms of cold and warm, it's actually quite good to have that bracketing information. So when we're trying to plot a probability of snowfall by air temperature or conversely rainfall by air temperature, it's really good to have those endpoints. So when it is really cold or if it is warm, I'm sure there is some point of diminishing returns, but in terms of understanding the hydrologic cycle and rain versus snow, we'll take whatever you're willing to share. It is, I guess, that narrower temperature range near freezing that's most critical, but overall, all these observations are useful.
So a question of clarification, when you say really warm and really cold relative to our freezing point, does really warm look like 45 degrees or 85 degrees?
85.
Okay, cool, thank you.
Good clarification question.
My pleasure, yeah. So the next question comes from Robert Paget. Are you there? Not, I'm happy to ask your question for you. Okay, I'll go ahead and ask it. And if you're here. Oh, you're here, great. Go ahead and ask your question.
Yeah, I was just wondering if there's a way to get sort of historical data of, you know, the weather, temperature, dew point, relative humidity. And I don't know if that's, you know, I know that like NOAA has stuff like that, or do you kind of correlate that with the data you're getting from this application?
I can answer that one as well. There are, and this has been a challenge for our project, there are many different weather monitoring networks, each of which seems to have its own data access protocol. So sometimes a lot of the time that we invest into the project is into accessing, downloading, aggregating, and quality controlling those weather data. Once we do that, we make them available with the data that we release with the project. So for the 2 years of Tahoe rain or snow, at the end of each season, we've actually released the quality control and anonymized data. And that includes not just the observations that were submitted, but also the additional data that we included with it, such as air temperature, elevation, and some of the other geospatial information I mentioned earlier.
And if later you do want tips on where to find some of that publicly available meteorological data that doesn't come from our project, feel free to email us or text us your email, and we can direct you in that way. David Robinson, you've got a question? David R.
Yeah, so I live actually right along the Rio Grande Valley in a rather isolated location, and we get almost no radar feedback on the current weather for either existing weather or predicted weather. So you mentioned earlier that when we have an observation to submit that's often, I'm not sure, calibrated with weather monitoring stations. And I'm curious as to if you have any notion of where the weather stations might be located.
Yeah, I can talk about the weather stations, and then maybe if Ben wanted to follow up with radar, he's the radar expert. The weather stations, even in the Rio Grande Valley, I could pull up a map after this, but there's usually going to be a fair number of them that report at least air temperature. So even if they're not a few miles from your house, there should be some that provide coverage within the valley. Radar, it's usually a different story. It's a much more expensive bit of equipment, and mountains do a really good job at blocking radar beams, not only from horizontal if they're ground-based, like much of the National Weather Service's radars are, but even the radars that are in space. So NASA's Global Precipitation Measurement Mission often can't observe precipitation near the ground surface directly. Typically it cuts off, it could be 1,000 feet, could be more or less depending on your location, but mountains and lots of trees tend to affect that sort of information. And then Ben probably has some better radar data than I do.
Yeah, and correct me if I'm wrong, Keith, but I don't think we're using radar to QC the observations. Is that right?
That is correct. So yeah, I should have mentioned that. We do not, we don't use that in the QC protocol just because there are so many holes in radar coverage.
Yeah, but I think it is great if you know you're in a location where there's poor radar coverage, being able to show these observations of precipitation where otherwise the radar doesn't pop up. That's really useful, and that could also help us extend the project and work with NOAA or other groups because they're very interested in, there's a few different projects going on of what's called gap filling radar, where they're trying to install find locations where we should put in different types of radar that may be a little less affected by this beam blockage, to try to improve coverage, especially in some of these really sensitive regions to either intense precipitation or rain on snow, or locations where we've had a lot of wildfire or have urban flooding kinds of issues. So it's, even if you don't get radar coverage where you're at, definitely submit observations. And then as far as weather stations go, yeah, it's kind of hit or miss. Sometimes you may have a ton around you, sometimes you may have less, but I think basically in all cases, the more observations that you submit, the better, because we can always go back and look and say, oh, why did a bunch of those from that location get QC'd out? Well, maybe there's not a weather station nearby to implement in the QC process, but we still have your data so that we can perhaps manually include it as well into the analysis. So I think the more data, the better is basically the long answer or short answer in this case. And then another thing to think about too is if you're traveling or hanging out in a location, kind of maybe going up or down, like even riding the chairlift, and you're going through that rain snow transition, that's a really, really great place to submit a lot of different observations, because that helps us at the finer timescales figure out when that rain snow transition took place, where in that temperature range did that occur, and how well are the nearby stations doing, because just in a very short distance, we can have a big change, especially if we have a lot of topography. And if you can get rain mixed snow throughout the course of the day, that can be really helpful for us to further figure out that really sensitive window of that transition temperature.
Nice. That's great. Eleanor has a question that was related. Did that answer your question, Eleanor, about local Met stations? Or do you want to expand on this?
Okay, I know where the Met stations are, and the mileages I gave are how far I am from them. So I was just wondering first if Vermont is helpful to the project, and if I'm too far away to be of any help. So I'm 12.6 and 22.8 miles away from two stations.
I would say keep submitting those observations, Eleanor. You are not too far away. Generally, the closer you are to a Met station, the more accurate of an air temperature value we can get. But this changes from study to study, but for the most part, a meteorological station within 25 to 50 miles, it trails off at the larger end of that range, will provide useful information. The other thing that's helpful is, particularly for this project, but probably life in general, is that air temperature is one of the easiest weather quantities to model or predict in different locations. So we have a high degree of certainty when we're monitoring air temperature and then trying to model it in different locations. We could compare that to the depth of precipitation that falls in a storm event, that you could be 1 mile away from a location and you get a totally different precipitation depth from a storm, whereas air temperature tends to be much more consistent and follows basically what we know in terms of physical relationships, such as elevational changes.
Okay,
so, yeah.
Oh, I'm sorry. That really happens here because the wind hits the common hill and we get snow dumped on when really close around here, there is not snow.
Yeah, and we live by Mallets Bay, Lake Champlain, and sometimes we'll get snow squalls at our house that my brother-in-law just down the road doesn't get at his house. So really neat meteorological phenomena, that's for sure.
Thank you.
Cool. Our next question is from Martin, and he's going to ask this question, and I'm going to ask our team to not only answer his question, but then build into the response just why we're focusing on mountain areas. What is it about high elevation areas that are of interest? Martin, are you there and want to ask your question?
Sure. Yeah. No. My question was, I live in Tahoe, but I'm not always in Tahoe. Do you want observations for where I am at that given time, or do you only want observations from the Tahoe area? My question.
So I can answer the first part, and then we can kick it to the teams. Yes, if you are on the road, if you are in the foothills or down in valleys of Reno or even Central Valley, that is helpful. Just like Keith mentioned about the range of temperatures, we are also looking for a range of elevations in proximity to mountains. And that's what kind of led me to prompt the team to say, why is it that we're focusing on mountains and surrounding regions? Why is it valuable to have that gradient of both, we talked about temperature, but elevation as well?
Yeah, Ben might have some useful information to follow up on with what I'm about to say, but mountains are in general unique, and then compared to low-lying areas near them. But they form a broader network of rain, snow, water cycling, et cetera. So we really want the valley observations, the mountain observations, the flat observations, because they really help complete the picture, particularly when we want to know where that elevation is, where it goes from rain to snow. The Sierras, I don't want to congratulate a mountain range too much, but they're some of the most interesting mountains anywhere in the world, because you can go from the Coast Range into the Central Valley, and then there's this huge fault block mountain range. And as you go up, you have these storms that only come from one direction, really. They come from the Pacific Ocean, and they hit this giant wall. And as they go up, they fundamentally change in character from the west side to the east side. So what happens to be rain down in Sacramento, you get a few thousand feet higher and it's mixed, and then it turns into snow. But then the rain and snow dynamics are different on the east side as they are on the west side, just because the humidity changes, the amount of moisture within the atmospheric river changes. It's just a really fascinating place. Never mind the fact that it only tends to precipitate a few months a year, and then it's just dry and sunny. So you really rely on those mountain snowpacks for water storage. Yeah.
Yeah, I would say if it's precipitating, please submit. Even if you're in the Central Valley, or even if you're at the coast, in the coastal ranges, we can get snow, and there's a pretty large network of observations in the coastal ranges. And we do measure snow at higher elevations or in these really, really cold storms. So it's, basically everywhere is great to measure, because at a larger scale, and kind of tailing on with what Keith was saying, we do see interesting signals of how the rain snow line changes with distance from the mountains. And so observations of rain snow transition, even in a different mountain range on the windward or further upstream side of the Sierra Nevada or Cascades, is really interesting, because that is kind of one big question of how does the snow line, it actually can bend downwards as you approach the mountains. And that's kind of a big open question in some mountain hydrology or research, and is really difficult for weather models to properly forecast. And so we're trying to further observe that to get an idea of, are we under or overestimating where the rain snow line is further upslope? Because a lot of our other kinds of measurements take place kind of in the foothills, and if the snow line is actually lower than that, we might overestimate how much rain is taking place at higher elevation, and then that feeds into not as good information into our hydrologic models, and we may overestimate stream flow or some of these other kinds of impacts. So, and then yes, if you're driving like across a mountain range and you go rain to mix to snow back to rain, all those observations are super helpful. The more we can get, the better, kind of as the general theme, I suppose. So the more observations we have as well, the more kinds of interesting questions we can start to address as well.
Yeah, thank you. And that was a great question, Martin, as a jumping off point, and I'll take it in one other direction. Sometimes we receive questions that have to do with the particular regions in focus. So at this phase of our funding, we are focusing on 5 different regions, which I'm sure you've seen in our keyword invitations. But we've also been saying, well, we want observations from wherever you are. So how do we score that? Well, ultimately, we are hoping to grow the project bigger. And if you've seen any of the social media posts by NASA, you might probably recognize that there are people all over the world who follow NASA's social media accounts and their press releases and things like that. And we are receiving observations from several other continents, including Asia, Europe, and even Africa. So that is really exciting. So we will not say no to any, even if right now we have capacity to focus on sending alerts to this core group of regions. So we really welcome observations from all over, not only the continent, but the planet. I'm gonna check out, why don't we have Tim come on?
Yeah, Tim, I saw you had a question in the chat to me. If you're not available, I can pose it and hopefully you're on. So I guess the first, and Tim, you can cut me off if you're logging in to talk. Tim suggested he's a participant in CocoRAS, which he offered as another way to do quality control. So CocoRAS, and Megan can explain a bit more about our engagement strategies, has been a very kind partner to us in terms of helping us get engagement off the ground. And I had not used CocoRAS data previously in quality control, but I have added it to my notes to look into. So thanks for that suggestion. And I don't know if Megan, you wanted to talk about engagement in our closing minutes and
Sure.
what he's worked on with other groups.
Sure, totally. So I can tell from your questions that you are all really, really knowledgeable, really informed citizen scientists. And we had a hypothesis at the outset that this type of project would appeal most strongly to folks like you and folks that care about the weather and folks that spend a lot of time in the outdoors using winter recreation. And so we looked to make connections via community partners like Coco Ross, like our avalanche forecast centers, like our weather service, like weather service connections and other kind of weather and climate related groups to share invitations to participate in the projects, because we wanted there to be alignment in values and interests as well as kind of intellectual orientation. And we have been so impressed at the high level of engagement with all of you. We have, let me check the number of reports that have been submitted just this season, so that have just come in since we launched in November, and that is 6,182 reports. This blows us away. We're thrilled beyond belief, and we really, really appreciate your participation. So I think we're gonna end there. There are a couple links that I'm gonna share in the chat right now for further reading. So feel free to, if this has piqued your curiosity, feel free to check these out, and also let us know. Okay, that means it was one to everyone. Feel free to let us know if you have any other questions. You've got access to us by text message. You've got access to us by email. We're here with you. So thank you again. Any final thoughts from the team?
Just thank you again. This project wouldn't exist without your observations, and it's been really rewarding for me, just not only in that perspective, but also we've presented some of this work at scientific conference, and it's not just the small project group with vested interest that's really excited about it. Our colleagues, people at NASA, are excited about it as well, and we wouldn't get that excitement if it weren't for you. So thank you. We appreciate you deeply.
I will stop the recording.